Okay, all right. Could you tell me about what are your goals and what you hope to get out of these sessions?
Well, I want to get more involved with coding, so that's why I booked a session.
Cool, okay. All right, and yeah, okay. So we'll be starting out in a language that's designed for beginners, and hopefully it will be a good way for you to start. I'm gonna send you a link on Zoom chat, and if you could open that up and then share your screen with me, that'll be great.
Okay, okay, can you see it?
Yep, perfect. Okay. All right. So to begin, I'd like you to think of two big numbers and add them.
Two numbers,
Yes.
so 5, for example, and 10.
Yeah. And let's add them.
Add them, right?
Yes. Okay,
Okay,
so at the top right of the web browser, there's a blue button called Run. Let's click on that. Very nice. Okay, so programming. Oh, by the way, you just made your first program. Congratulations. But programming is
thanks.
like using a calculator, but it's not surprising because a calculator is a computer, right?
Right,
Hmm. Let's take this further. Could we add a third number in there?
sure. Let me 30, for example, and 1.
Nice. Okay, let's try something different. Could we change one of the plus signs to a minus?
So run again. Oh,
What's happening here?
I have no idea.
Okay, so it says the plus and minus operations are at the same grouping level. Add parentheses to group the operations and make the order of operations clear.
Oh, so I do it among 5 and 10?
For example, yeah?
Okay,
Okay,
will it
let's see if
work
this
now?
works.
Oh,
Nice.
nice.
So that was basically saying it didn't know whether or not to add first or subtract first. You have to tell it.
I got it.
And you decided to add first, so that's cool. So in mathematics, are you familiar with BEDMAS or PAMDAS?
No. What are those?
It's okay. It's a convention mathematics, for example, that we should multiply before we add. Um,
Uh-huh.
that does not exist here. There is no convention. Whenever you have mix of mathematical operations, you need to have parentheses to specify which should happen first. So in this case, plus should happen first. Okay.
I got it. Yeah.
All right. All right. Let's multiply this whole thing by another number now.
Um, okay. Oh, again.
Hmm.
I should put another parenthesis.
Yeah. Very
Okay.
nice. Okay. So we add first and then we multiply and then we subtract everything. Okay. So
Mm-hmm.
notice how there's a sequence of steps that the computer must take. We call this an order of operations. In what order does it operate on the numbers? Yeah.
Yeah.
Okay, very cool. Let's try something different now. Let's delete everything.
All right.
Okay, now I need you to humor me for a second. This will sound funny, but first, write two numbers separated by a comma,
Hmm.
and then I'd
All
like you to
right.
surround everything in parentheses.
Sure.
Before the first parentheses, could you write NUM? Before the
Where
first
exactly?
parenthesis. Oh yeah,
Oh, what should
where
I
you're at.
write?
NUM.
Sorry, I don't get it. What should
Oh,
I write?
oh, it's a series of letters, N.
Uh-huh, N.
Oh, but lowercase.
Uh-huh,
Yep.
this. All right.
Dash. Oh, dash,
Okay.
like a hyphen, like minus, minus sign, and then MIN.
Yeah, 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 I got it.
Okay.
Okay.
Now, before we run this, what do you think is going to happen?
Probably, okay, if this MIN is short for minimum, probably it's gonna give us the minimum between these two.
Okay. Let's run it. Let's see what happens.
Okay. Oh, nice. So
Okay,
what
what's
is it?
happening here? Okay, so it's saying function calls must not have space between the function expression and the arguments.
Oh,
Ah, okay. There we go. Okay, let's test our hypothesis. Could we change the numbers a little bit just to make sure that we're really sure it's really getting the minimum?
okay. Should I go a higher number or just lower? It
Yeah.
doesn't matter.
Yeah, I mean, I think a higher number will work. If we make 26 higher, let's see if we get 55, right?
Yeah, I guess. Let's do it. 100.
Nice.
Okay, nice.
Okay, so yeah, it's giving us the minimum.
Mm-hmm.
Uh, so what's interesting is that we're using like symbols like plus and minus, but now we're using a word, not min.
Mm-hmm.
Okay. Um, let's try something. Let's add this to another number. Like, don't delete anything. Add this whole thing to another number.
Like copy paste it again, another thing, or
Oh no, just add it to another number. So plus and any number.
uh-huh.
Yeah.
I got it. Or should I go non-min again or
You
just
could, but I kind of want to stick to a number for now.
uh-huh,
Just
okay.
yeah, because that's one thing I want to show.
Mm, all right.
Okay, let's try running this.
Space or what?
So okay, let's read what this says here.
Um, I don't get it. What's the problem?
So it's saying the operator must have white space separating it from its operands, right? So white space is basically space. So there's got to be like blank space around the plus sign. Yeah.
Got it. Oh, nice.
Okay. So notice how we can mix and match like worded operations and symbolic operations.
Yeah.
The numin and just the same way we can minus and plus, we can do numin and plus. Okay.
Mm-hmm.
Um, well, there's not much difference between the symbols and the words actually. They're all just performing operations on numbers, right?
Mm-hmm.
Okay. We could also move the plus 22 inside the parentheses.
Like plus and is 22
Yep. We
or
could move
just
that. Yeah, let's highlight that and let's cut it.
okay, is this
Yeah, and let's move the 22 as well.
okay.
Yeah. Let's see what happens here. Okay, we got the same thing. So
Yeah.
it might not seem like there's a difference, but the difference is the order of operations. Here, the addition happens first and then the minimum. Just now, we got the minimum and then added that to 22. Yeah?
Mm-hmm. Got it.
Okay, so it's a subtle difference. Okay, anyway, to summarize everything that's happened so far, we have covered the laws of arithmetic. We did plus minus minimum as well, multiplication on numbers. We've performed some operations on numbers.
Mm-hmm.
Let's move forward in time a little bit and let's go to algebra. Okay, let's delete everything here. And I'd like you to write
Okay.
x equals 1.
With space or without it?
It actually doesn't matter in this case. Yeah.
Okay.
And on the new line, let's write x. Okay, great. Now, before we run it, what do you think is going to happen?
It's probably gonna give us one.
Okay, let's see.
Okay. Mm,
Yeah. So x gets the value 1, and when we see x, we see 1. So this is variable substitution. A very important idea in algebra.
Mm-hmm.
Okay. Now can we change the x on line 3 to x plus 1?
Okay.
And
Oh,
yeah, okay. So on line 3 we get x, so that's 1. And then line 4, the x becomes 1, so it's 1 plus 1 is 2. So you get 2.
mm-hmm.
Okay, so far
I
so
got
good.
it.
So yeah, basically same as algebra, we can mix and match variables and numbers. The variables will become numbers and then we add the numbers together. Okay.
Mm-hmm.
Let's try something funny. Can we change line 3 to x equals 2?
All
Oh,
right.
x
Oh,
equals 2. Yeah. And before
my
we run
bad.
it, what do you think is going to happen?
So the first time it showed us one, so now I'm not sure. It's gonna show us the second one and we'll add the second one to this. I don't know.
Okay, that's a good guess. So would you say that the answer will be 3?
Yeah,
Okay, let's
that's
run it and
fine.
see.
Oh,
So what is it saying?
oh, it's like two values for x.
Well, the declaration of a name conflicts with an earlier declaration of the same name. So
Mm-hmm.
there are two things here. First is the idea of a declaration. When we say x equals 1, we're saying we're declaring x as 1. To
Mm-hmm.
declare is like saying like, oh, now x is 1. But later we're saying, oh, now x is 2. And this language in particular doesn't like it. Now, it's important to note that different programming languages will have different results here. In some languages, you will actually get 3. But in this one, it doesn't like it when you try to declare a variable of the same name. Some intuition as to why this might be the case is that imagine we are mathematicians and we write x is 1, let x be 2, x plus 1. Now, as a mathematician, if we write x plus 1, let x be 1, and let x be 2, why did we say x be 1 in the first place?
Yeah, exactly.
Um, Another idea is that, for example, like let's say that there's a declaration of independence. Once you declare your independence, you've declared it. It's set in stone. It has happened, right?
Mm-hmm.
Um, this will be an idea we'll re-explore in the future, but for now, just know that you cannot declare a variable with the same name. It has to be unique.
So I should just delete one of them.
Oh yeah, that's really one of them. Which one do you want to keep?
Yeah, I will delete the first one.
Okay. Let's run it again just for sanity. Great. Okay.
Yeah, three.
Very good. Okay, so we have covered a little bit of algebra. We have variables and variable substitution. Let's go over another key idea of algebra, and that's functions. Okay,
Okay.
what is a function?
Um, I'm not sure.
Okay, so we'll write one first, and then we'll go over what it is. So let's delete everything, and let's write
Okay.
fun. Okay,
Okay.
notice how it's bolded. So it's a special keyword. We're telling the programming language we are intending to write a function. Right now,
Yeah.
space.
Okay.
Let's call our function f. So let's say f opening parentheses x closing parentheses colon
Is it
new
this one?
line. Yep, that's right. Let's do a new
Okay.
line.
Okay.
X plus 1 new line end. Okay, notice
Um,
how it's all highlighted now. So this
yeah.
is a function. We have just defined a function. Okay.
Mm-hmm.
So what
Should I
is a
run?
function? If you can actually run it right now. Yeah, let's run it and see
Okay.
what happens. Nothing
Nothing.
happens. Okay, so
Okay.
that's because a function, it doesn't do anything yet. It's just a thing. What is it? So a function is something that goes from inputs to outputs.
Mm-hmm.
Yeah, you give it some stuff, it gives you some stuff back. Okay. So
Okay.
That's just functions. For our function in particular, what we just defined on line two, that function, it has three things. The first thing is that it has a name. This function name is called f. Why do we need a name? We'll get to that in a moment. The second thing is that it has inputs. So in this case, this function takes in x. It takes in one thing, and it calls it x.
Mm-hmm.
In programming, we call this input parameters. So we say that a function f has parameter x.
Got it.
The third thing, the function must produce an output. It must give something back. How does it know what to give back? It does, it has a body. So the x plus one, we say it's the body of function f. It computes the body, gets an answer, and gives it back to whoever's using this function.
Uh-huh.
Okay. And the end, the n, it denotes the end of the body. So once we see n, the function knows, oh, that's the end of the body. I'm only doing x plus one. Okay.
Okay.
Okay, cool. So the reason why nothing happened once you run it is because we didn't actually use this function. We've just defined it.
So what should we do?
Okay, so let's use this function. In mathematical speak, we say we apply a function, but in programming, we say we call a function. So let's create a
Uh-huh.
new line in our program,
Okay.
and let's do f opening parentheses and any number you want.
Mm, all right.
Okay, that's closing parentheses. Cool. Now let's run. Let's see what happens. 26.
26.
So why did we get 26?
Well, we just call the x here, which happens to be probably this 25.
Yeah.
Uh-huh.
Okay, and x becomes 25, and then on line 3, 25 plus 1 is 26, right?
Mm-hmm. I got
So
it.
again, the idea of inputs to output, the input is 25. The functions, oh, it's 25. Okay, x is 25, 25 plus 1 is 26. It does the body. It gets the answer, which is 26, and it gives you back 26. That's the output.
Mm-hmm.
Okay. Um, great. Let's do something a little bit different. Let's notice how there are two windows. The one on the left is sort of where we have been doing our things. And the one on the right is sort of been giving us answers, right?
Right.
I'd like you to click on the window on the right.
Okay.
Uh, so notice how you can type stuff in here. Let's call a function with a different number.
Okay, like the same thing I should do?
Yeah.
Or
Oh, but not define a function. Let's call a function. So
uh-huh.
we refer to it by its name, and the name is f. Yeah, so it's just f, opening parentheses,
Okay.
and any number. That's different.
Hmm. All right.
Okay, very nice. Let's closing parentheses, and let's hit enter. 7. We
Oh,
get an answer.
nice.
Okay. Notice how
Just
we got
gives
an
us
answer immediately.
directly.
Exactly, yeah,
Yeah.
it gets us directly, right? And just now we had to hit run, but here we didn't hit run. We just hit enter and we got an answer immediately.
Mm-hmm.
So there are a few things to note here. First, notice, okay, there are two windows. The one on the left is our actual program. We call this the definitions. This is where we define our program. Okay.
Okay.
And that's why we say we're programming. We are making the program. The one on the right, we get our answers here. And we can also sort of notice how we were able to call our function f in here.
Yeah.
It's it we define our function f on the left-hand side, but we could use it on the right-hand side. Okay. And we can sort of
Mm,
write one-line programs on the right-hand side, hit enter and get an answer immediately, right?
I got it.
So we call this the REPL. That's REPL. It's an acronym. And it's R for read. It reads what you write. So F of 6, it reads that. E for evaluate. When we say evaluate, we just mean simplify. For example, F of 6, it simplifies into 6 plus 1, which simplifies into 7. So
Mm-hmm.
evaluates. Another way of understanding evaluate is that it means to turn into a value. to make a value. So that's why it's the word
Mhm.
value in evaluate. So a value in programming is just something that cannot be simplified anymore. So seven's a value. It can't be simplified anymore.
Mhm.
Um, so it reads what you write, evaluates it. When it evaluates it, it gives you an answer. So seven's an answer. And then it prints the answer. That's P. P for print and L for loop. Because you can keep doing this again and again. So REPL, read, evaluate, print, loop. You don't need to know this, but I'm telling you now. So when I say REPL, you know what I'm referring to.
All right, thanks.
Yep. Let's do something. Can we call a function again? Call a function f on a different number in the
Here
REPL.
again.
Yeah.
Okay.
And let's add another. Yeah, let's do a
Any
number in
same
here.
number?
Oh,
Okay.
let's do something different and let's add this whole thing to another f of another number.
Um, Another what?
Another number. Yeah, so f opening
Uh-huh.
parentheses and any number.
Okay. Like so 10.
Perfect.
Okay,
Yeah,
should I
that's
hit enter?
yeah, nice.
Hmm.
So the same way that plus and minus can mix and match, our functions, we can mix our plus and our function f, right?
So
And
it's like
mhm,
they separately did the math because of the function and then added those two together.
exactly, yeah, the function call happens first. So 22 becomes the f of 22 becomes 23, the 10 becomes 11, 23 plus 11 is 34.
I got it.
Yeah. Yeah, so it's back to the idea of order of operations. The function calls happen first.
Mhm.
And this is actually very similar to what we did with nummin, if you remember.
Yeah.
In fact, nummin is a function call, but it's a function that is provided by the language. You didn't have to define it, whereas f here is something that we defined. Okay?
Oh, yeah.
Okay, so when we write mathematics in real life, we tend to use very short names so that we can write less. But in programming, it's very easy to type stuff in. And so we tend to want to use descriptive names. F isn't very descriptive. When we say F, it's like, oh, what does F mean? Right?
Mhm.
Like just now when we saw num min, we knew, oh, it's getting the minimum. We were able to deduce what the function does from its name, right?
Mhm.
Okay, let's change the name of this function. Could we go to the left-hand window? Can we go to definitions? And let's change the name
Okay.
F to something else.
Like what? A letter again?
Oh, let's find what's a good name for this function that's descriptive.
I'm gonna go with math. Can I?
Math. I mean, you could, but I feel like math is also very broad, right? Math is a huge
Yeah, it
subject.
is.
Yeah, could we be a little bit more specific than math?
Hmm. Actually,
Well,
I have no idea. Can you offer or recommend something?
well, what does this function do?
It adds numbers,
Adds numbers, but what numbers specifically?
the input, the number that we give it.
Okay, and what does it add it by?
Um, One,
One. Adds one. It adds one
right?
to the number you give it. So perhaps add one would be a good name.
Uh-huh.
What do you think?
Okay, that's good, I guess.
Okay, let's do it. All right, so let's do add.
And
So we use dash
like
or like
this.
so you could, but conventionally in this language at least, we instead of using underscores, we use the minus sign or dash.
Uh-huh, okay.
Yeah, add one. So this is similar to nummin, but instead it's yeah. Okay. Let's run it and see what happens.
Hmm.
Ah, so what is it saying?
Well, we changed the name, so it doesn't recognize it anymore, I guess.
Exactly, right? Yeah, we changed its name, so F means nothing now. So how do we fix
Yeah.
this?
So, I mean, we changed the F here as well.
Yes, perfect.
All right.
Yeah, and that's why the name of the function is important, so that we know how to refer to it. Yeah,
I got it.
great. Okay, so just to summarize everything we've done so far, we have worked with numbers, we've used this like a calculator, we've covered the laws of arithmetic and a little bit of algebra to the extent that we can do variables, variable substitution, and functions.
Mhm.
Okay, very nice. We're gonna switch gears a little bit, and so I would say we're doing the mechanics of programming, but there is a layer of programming that I now want to introduce that it sounds like that can sound a little bit funny at first, but I want you to humor me. Okay, I want you to delete everything in our definitions
Okay.
and just write the number five, and
Mm-hmm.
let's run it. Okay, five gives us back five. No, no surprises. Well, I've got a
Mm-hmm.
question. What does five mean?
I don't know. Something, I don't know, actually.
It's somewhat of a trick question. Five is five, right? Doesn't really mean much.
Yeah.
Okay, now what if I say what is 5 degrees Celsius?
Well, then that becomes temperature.
Temperature, how cold, how hot it is. Okay.
Yeah.
What if I say 5 kilograms?
Well, it's the weight of something.
The weight of something, how heavy, how light it is. No, but
Yeah.
they're all five, right? But depending on
Yeah.
whether or not I say 5 degrees Celsius or 5 kilograms, it means something a little bit different, right?
Mm-hmm.
Okay. So there are two worlds. There's the world of information. This is ideas and facts about our real world. So like 5 degrees Celsius. And there's the
Mm-hmm.
world of data. This is what the computer sees.
Mm-hmm.
When we say 5 degrees Celsius, the computer is just going to see five. It doesn't know its temperature.
Right.
That five in front of us in our program, that's data. You and
Oh,
I,
so
when we
this
say,
is
Mhm.
this is data, like.
Yeah, in
Mhm.
front of us, yeah, this the five we just wrote, that's data.
Mhm.
Now I could tell you, hey, that five is actually temperature, it's 5 degrees Celsius. You and I, we know that's information, but the computer doesn't know that.
Mhm. True.
Okay. So this sounds philosophical, but it's a practical idea. Because my claim is that our role as programmers is to translate between the world of information and the world of data. We turn
Mhm.
information to data, perform operations on data, and then turn that data back into information. Okay?
Yeah.
For example, like let's say we have an electronic thermostat. That electronic thermostat has physical sensors that senses the environment, like electrical resistance or the molecules in the air, and it turns all
Yeah.
that information into numbers in its machine.
Mhm.
Like, and then it uses its machinery to compute on those numbers and deduce the temperature. But the thermostat doesn't know it's the temperature. It just does a bunch of mathematics and determine a number. It displays the number on some screen, and we as humans, we can read it and say, oh, it's 5 degrees Celsius right now. We turn that data back into information with our human eyes, right?
Mhm.
Okay. So that's an example of how we go from information to data and data back into information. Okay.
Right. Yeah.
Okay. That's so just to reframe everything we have done so far, what we have done is we have encoded information as numbers. When I say encoding, I mean we have turned our information to numbers and we have dealt with numbers. Okay.
Okay.
Now, I got another question. Can we encode all information as numbers?
Um, Probably not. Probably we need words too.
Words, okay. I have a counter argument. Uh, do you know the saying that computers are just a bunch of zeros and ones?
Oh, yeah. Yeah.
And zeros and ones are numbers, right?
Yeah, I guess.
So everything are numbers. We can encode all information as numbers.
Mhm.
Okay, now the next question is, do we want to? Do we want to encode all information as numbers?
So I guess for the computer to understand it, we gotta do
Okay.
that.
Okay. Now I'm gonna introduce an idea of programming, and which is
Okay.
that when we program, it's not actually for the computer. Yes, the computer should understand it. However, I claim that programming is actually for humans.
Uh-huh.
There are programs right now, as we speak, that are running, that's been running for longer than we have been alive.
Hmm.
Like there are programs that have existed since like the beginning of programming that are still running, like credit card systems, banking systems, that like cannot stop or like financial systems will crash.
Hmm.
But who creates those programs?
I
Those
mean, human.
creators, humans created those programs, and those humans they're gone or
Yeah.
either retired or dead. And so new humans must come over and maintain those programs, right?
Hmm.
So those programs, humans must understand those programs.
So that's why we have programming languages.
Exactly, yes. We don't write in zeros and ones. We write in higher level things. Yeah,
Yeah.
fair. And so my first question was, do we want to encode all information in numbers? And the answer is no. For example,
No.
you said words, right? Like you and I, we are talking right now, but we aren't talking in numbers. We aren't talking
Yeah.
in Morse code, right?
Yeah.
We're talking in language. And language, they aren't numbers. Okay. So the key idea here is that we do not want to just encode information as numbers. We want to encode information as other things. Now, what are the other things? We shall now introduce a new way of encoding information. And now we are going to cross the boundary where we are using a calculator. We're going to be beyond using a calculator now because we're going to work beyond just numbers. Let's
Hmm.
delete that five. And could you write double quotes? Hello,
Hmm.
comma space world.
Inside it.
Yeah,
Okay.
great. Okay. Um, let's hit run and see what happens. Hello world. We didn't get back a number. We got back something different. An
Hmm.
entirely different animal. We got back a string. We call it a string because it's like a string of characters.
Hmm.
Okay, so just now we've been working with numbers, but for the first time we're working with something different. We're working with a string. And it encodes different information. It's not numerical information, it's these are words. We're telling the world hello. Okay.
Hmm.
So for this example in particular, there's a historical explanation behind it. In 1970s, there's a book on how to learn how to program that used this specific example, Hello World. And ever since that day, every book, every tutorial, every video course, every lecture uses this example, Hello World.
Nice.
So it's like a rite of passage. So congratulations, you have reached a very important milestone in your life. You have said Hello World in a program.
Mhm. I see.
So very cool. Okay, so our Zoom session is gonna kick us out because I did not pay for a subscription. So I'm gonna close this one out and send you a new link on Gmail. All right?
Okay, sure.
Okay, so I'll see you in a minute.
See you.
Okay, so hello world. Okay, so just now we had numbers and we were able to perform arithmetic on numbers. Could we perform arithmetic on strings? Can we add this string to another string?
I guess. Yeah.
Let's try. Let's see what happens.
What should I write?
Oh, anything.
Okay.
Perfect. Okay, let's run it. Hello
Um,
world, how are you?
it did, but like without the space, I guess we should add here probably.
Okay.
Hmm.
Hello world, how are you? Perfect. So the same way we can add two numbers, we can add two strings. We can
Hmm.
perform arithmetic on strings, right?
Right.
Now, could we change the plus to a minus? Let's see what happens.
Is it gonna work?
I don't know. Let's find out.
Okay.
Oh,
Oh.
Let's see what it says.
Mm,
The minus
gonna give me
operator.
numbers.
Exactly. So it doesn't work.
Hmm.
But it also doesn't make sense. Like, what does it mean to subtract two strings, right?
Yeah.
Yeah. And so arithmetic for strings means something different than arithmetic for numbers. We can't subtract
Hmm.
strings. Okay. Okay, that's interesting. Okay, could we I'm gonna go back to a little bit of philosophy again. Could we delete everything in our program? And I'd like you to write double quotes and just five. Just the digit five. And let's run it. Okay, nothing surprising. The same way we said hello world and got back the string, we wrote five and we got back the string five. Okay, now in a new line in the program, could we write the number five, non-double quotes?
Um, would you repeat it again, please?
Oh, could you write the number five? Just a
Okay.
number. Great, and let's run it. Okay,
Hmm.
so we see a five in quotes and five that is just a regular number. Okay, I have a question. Now that we have strings, and strings are a series of characters, and to write a number, we had to write a series of characters. Why do we need numbers? Why not just make everything strings?
Mm, probably here it recognizes this five as a string because we have like a double quote, but here we don't.
Yeah. And so why not put everything in double quotes?
Because if so, it wouldn't do the math part.
Ah,
Am I right?
yeah.
Hmm.
They're operationally different. Their operations are fundamentally different. So what this means is that while we can while the same piece of information can be represented with multiple data types, like for example the information five, we have two ways of saying that here. There are strengths and weaknesses to each one. If, like, for example, we can subtract numbers, but we can't subtract strings, right?
Right.
Yeah. Okay. So, just to summarize, we have worked with numbers and strings, and we have learned that we can do quote unquote arithmetic on each one of them. But arithmetic means something entirely different for strings. Okay.
Hmm.
All right. So we've covered two data types. So the word data type means classification of data. We say that a number is a data type, a string is a data type.
Hmm.
Okay, we're going to introduce another data type here. So data types, they encode an important piece of information. Numbers, they encode like, like math stuff. Strings, they encode words. Another important piece of information that we want to encode is decisions. Decisions are important. It can be said that life is a series of decisions where a decision is either yes or no. For example, your decision to come to this office hours, you must have said yes.
Hmm.
The idea of decision is very fundamental. The idea of yes or no, on or off, right or wrong, true or false. This idea of duality. This
Hmm.
data type, we call this booleans. Boolean is named after a person named George Boole. He is a mathematician who studied these things as mathematical objects. In programming, we use the words true and false. So let's delete our program again and let's write true. That's TRUE, all lowercase. Now notice how it's red in color.
Yeah.
Okay, let's run it and let's see what happens. True. Okay. The same way we wrote a number and got back a number, we wrote something true and got back true. So true is a value in this language. And
Hmm.
special. Let's replace true with false. 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 Okay, let's run it. Right. Notice how it's red in color and we got back false. Okay.
Yeah.
S- So there's a very important characteristic about Booleans. So for numbers, right, we could go 1, 2, 3, 4, 5, 6, 7, 8, like many, many numbers. For strings, we can say many things with strings. We can say hello world, we can say how are you? But for booleans, there are only two values. It's either true or false.
Mhm.
Okay, and it's nothing more than that. There are two values for booleans. Okay, so this is our third data type and is used to encode decisions. True or false, yes or no. Okay, so the same way that we can perform arithmetic on numbers and strings, could we perform arithmetic on booleans? I would like you to now write false or true. That's OR, lowercase, and then true. Notice how the OR is bolded, and let's run this and see what happens. True. Great.
True.
All right, let's replace the OR with an AND. That's AND, and let's see what happens. Very nice.
Mm.
Okay, so we went from two booleans and we ended up with one. All right. The same way we can
Yeah.
add numbers, the same way we can add strings, we could also add booleans. Okay,
Mhm.
very nice. So this thing in the middle, the and the or, the thing that's bolded, we call those Boolean operators.
Mhm.
They are what we use for arithmetic for booleans. Okay, I'm going to share my screen and show something real quick. Give me 1 second.
Okay.
Uh, okay, let me know once you see my screen. Oh, wait.
Well, I can't see it for now.
You see it now?
No. Should I stop mine? Probably.
Okay, yeah, try stopping yours. Let's see if that helps.
Yeah, I can see it now.
Okay, great. Okay, so here is a bunch of tables and some diagrams. It looks like a lot. It's actually very easy to understand. So
Mhm.
another way of understanding Booleans is that they encode truth, whether or not something is true. Zeros means false and one is true. And so these
Mhm.
tables, they tell us what the operators do. So just now we wrote false and true is false, like this row here. 0, 1 is 0.
Yeah.
False or true is true. 0, 1, 1. So this table gives us the answers to Boolean operators. Okay.
Mhm. So 0 was false and 1 was true.
For this diagram, yes. But
Mhm.
when you're writing in Pirate, in a programming language, you want to write false and true.
Mhm.
In some languages, you can actually write 0 and 1, but I don't think that'll work for us.
Mhm.
Oh,
Nice.
okay. Remember how I said that computers are a bunch of zeros and ones?
Yeah.
These are the zeros and ones. These are it.
Nice.
These diagrams here, these shapes, these are logic gates. These are very tiny physical devices that take in electrical signals on one side and produces another electrical signal on the other. So for the AND
Mhm.
gate, if there's one wire that has electricity and the other wire that doesn't, this resulting wire does not have electricity in it. Okay?
Mhm.
And so these tiny things are the building blocks of our computers. We have hundreds, thousands, millions, billions of these very tiny things that make up our computers, and they can do amazing things. Okay? And
Interesting.
so our computers are a soup of zeros and ones, and these logic gates are stirring the soup, changing the zeros and ones. This is what makes computation possible. Okay?
Mhm.
Now, as programmers, we don't really need to know this. I'm telling you this just to blow your mind. But as programmers, we
Okay.
only need to care about three things. We need to know not. So the not, it flips the Boolean. It turns false into true and true into false. And or. These three things.
Mm-hmm.
Um, for the other Boolean operators, you don't really need to know those unless you're an electrical engineer or maybe you're in cybersecurity or you want to write really performant algorithms where you need to get like when you're like you want to write algorithms that run really quickly and you have to work with really low level things such as these. You don't have to know them. You just need to know not and or.
All right.
Conceptually, these are like functions. Notice how it says inputs and outputs. They take in booleans and they produce booleans. I say conceptually because there's a caveat, but we'll get to that in the future.
Mm-hmm.
Um, okay, so yeah, these are truth tables. These are the definitions for Boolean operators. And we work with Booleans now. There's arithmetic for Booleans. And what we could do with Booleans, we use Boolean operators. And these are the rules for how Boolean operators work.
I got
Okay,
it.
all right, I'm going to stop sharing my screen now. Could you share your screen again?
Sure.
Okay, so as you do now, I'm just going to summarize everything we've done so far. We have covered numbers, strings, and booleans, and we can do arithmetic on each one of them. But arithmetic looks very different for each one. Okay,
Mm-hmm.
so you can get very far in life with just numbers, strings, and booleans. They're like cash. If you're lost in a city, but you have cash, you can probably get what you need, right? If
Mm-hmm.
you have a piece of information and you want to encode it, there's a very good chance you're probably going to use one or more of numbers, strings, or booleans. Okay. Right. There is one more cool thing I want to show you. Let me pull it up real quick. I'm not gonna share my screen. I'm just gonna paste something in chat. I'd like you paste it in your code.
Okay.
Give me 1 second. Okay, so I just pasted code in Zoom chat. Could you copy that and paste it into your program? But don't run it yet.
Should I delete
Oh yeah,
these
let's
or
let's
just
delete it. Yeah, we can delete
okay?
that. Okay, before we run it, what do you think this is gonna happen?
I don't know. Okay, probably no, I don't know.
Okay, just give a guess. Any guess.
Probably it's gonna write this, and I'm guessing this is the size, the color. I'm not sure about this.
Okay. All right, let's run it and let's see what happens.
Oh, it's a shape
Oh,
actually.
it draws a circle.
Nice.
Okay. Could we change the number and see what the number means? Five. Okay, 50. Nice.
Yeah, size.
Size. Okay. And how about the red? Could we change some words for the red?
Hmm,
Purple. Nice. Very cool. So that's
nice.
color. You're probably wondering about solid, like what we could change that to.
Yeah, what will happen if I delete it?
You can try.
Okay. Huh. I don't know what happened.
So there's nothing between the commas, right?
Yeah.
So the programming language is confused. It doesn't know what to do with that.
So what if I delete like one comma? Let me
Okay,
see.
let's try it.
Again? Probably there's a rule to it that you should have that part.
Yeah. Yeah, I mean
Hmm.
let's read the error message here. The text here. Two arguments
Hmm.
were passed to the operator. The operator evaluated to a function accepting three parameters.
Three.
Yeah.
Right.
So
So
remember
what
how we
was that?
defined a Mhm.
No, continue, sorry.
Oh, I was just saying that. Remember how we defined our function just now, f of x, or add on x?
Yeah.
We said that was one parameter, right? And we had to give it one thing. Yeah.
Hmm.
Here, someone in the world has defined a function called circle, and they have defined it to take in three things, right?
Hmm.
Now you're probably wondering, okay, so what three things are they? So we know it's solid, but what else can we change it to, right? It's
Hmm.
like we need to find the person who created this and ask them about it. Okay. But I don't know who made this, but we don't have to. So when we're learning a language, I mean in real life, like a natural language, we often use a dictionary. When we see a word we don't understand, we use the dictionary to find out more
Hmm.
about the word. Likewise, in programming, we have a dictionary for these things, but we don't call it a dictionary. We say it's documentation. So for your benefit, I'll send it to you here, but we are running out of time. Um,
Okay.
let me. I'll send you the dic. If you wish to play with this at your own time, you may. I'll send you the dictionary. So yeah, I just sent in Zoom chat. You can find out more about this. So in this dictionary, you can search up terms. You can search up words. You don't have to flip through pages. Like the top left search bar, you can just put in circle.
Here.
Oh yeah, search manuals. Yeah, right there. So if you just type in circle here, yeah, that's the one. And then
Oh.
so I think you scroll past it. It's a little bit above. Yeah, so we see circle takes in three things, and now you know what it is: radius, fill mode, and color.
Hmm.
So this is the top of the function. We call this the signature. This is the name and its parameters. This is data. This is what you see there, circle, radius, mode, color. That's what the computer understands. Below that, you see a description. Constructs a circle with the given radius, mode, and color. That's meaning. That's for the human. That's information. So again, back to the
Hmm.
idea of information and data. Okay. All right. So yeah, I encourage you to play around with this. And I don't normally assign homeworks unless you want homework, in which case I can give you homework. That's not a problem. Just the pace in which you progress is up to you. And
Okay.
yeah, so to end my sessions, I often like to ask my students, what is one thing you learned today that stuck with you?
Mm, so that, let me think.
Hmm.
So, a question before it. So the thing that we did, we gave, for example, this number to x. What is the x here? The data or
Oh, that's a variable.
a variable? So one thing that was interesting was that here we cannot give two values to a variable,
Mm,
and also REPL that we talked about that we can enter something here and just get it right away.
mm,
That's two.
cool. Very cool. Yeah. Okay, yeah, I encourage you to play around with this. Yeah, this is a very fun thing to do. And I'm very glad to help you on your learning journey, and I hope to see you again.
Thanks. Thank you so much for
All right,
today. See you
no
too.
problem. Bye-bye.
Goodbye.